This is Venkatramana. Today's class, 8th class physical science. First unit, force. In this force chapter, we already completed regarding force and regarding types of force. What are the types of forces? Contact force, forces at a distance. Contact force and forces at a distance. Force at a distance also called as gravity. Force at a distance also called as field force. Field force. Now, in forces at a distance, we already discussed about magnetic force. With the help of magnetic needles, we discussed that in last class. Now, let us discuss regarding visualizing a magnetic force. Visualizing magnetic force. Visualizing the magnetic force, which we'll call it as field force or forces at a distance. Forces at a distance. Now, how to visualize, how to see that force? Now, you take one pad, or you take one plank, or you take one table. On that table, you fix white paper. Now, let us think this is a table or plank. On that plank, we'll fix a white paper. We'll paste white paper, or we'll pin the white paper. On that white paper, now place one rectangular shaped magnet. Rectangular shaped magnet. Such that every bar magnet will have two poles. One is north pole and other is south pole. Now let us assume that earth directions are north, south, west, east. In this way we have a earth directions. Now this as magnet have two poles, two ends. Now let us place north pole here, south pole here. Means south pole of a magnet facing north pole of earth. North pole of magnet facing south pole of earth. In that way we place it. Now we have to take iron fillings. Where will get this iron fillings? If you take this bar magnet and if you place in the soil, or if you place in the mud of a ground, of our school ground, or in our home, if you have soil, there if you place and if you just roll here and there, then if you take out that magnet will attract some pieces of bits of pieces of that soil, which will call it as iron fillings. That you have to take out and you have to collect in a white paper, and that iron fillings, that will call iron fillings. Small pieces of iron you will call it as iron fillings. That iron fillings you have to take and you have to sprinkle. Now this is a cardboard. Now let us assume that this is a cardboard, and on this cardboard we'll place magnet. We'll place one magnet, and iron fillings we have to take. Iron fillings you have to take and sprinkle. You should not throw. You have to sprinkle iron fillings. We have to sprinkle, just you have to drop. Generally, without this magnet, if I sprinkle these iron fillings, they will fall and form a heap. Means which will call it as a kupa. Then will form as they'll fall as a heap. But when you place magnet in such a way that north pole of magnet facing geographical south and south pole of the magnet facing geographical north, and if you sprinkle iron fillings, all that iron fillings will fall as a certain in a uniform pattern, certain pattern way they will fall, or in simple language, in a certain design way they will fall, and they can able to appear as some lines, imaginary lines. They will be appeared as some imaginary lines. In this way, they will fall on this white paper or on this cardboard. In this way, they will fall. One more line let me draw. Here they should not be. They won't intersect. They are closed loops. Loop means which doesn't have any end point. In this way, in a certain pattern way, in a uniform way, or in a certain designed way, they will form. Now the question is, why the iron fillings, instead of falling zigzagly, instead of falling randomly, why they fall in a certain uniform pattern, or why they fall in a certain designed pattern? Why they will fall in a certain designed way? Because in the surrounding of this magnet, up to means the space around the magnet, in that space up to certain region, this magnet will influence its force of attraction or force of repulsion. That means these iron fillings generally will attract towards the magnet. Since we have a attractive property at these places, in this region, in that region they fell. That means wherever they fell, or wherever you have pattern, there we have a attractive property. In that region they have attractive property. That's why they went in that way, and what we call they fell. And appearing as a certain pattern design or certain uniform pattern. These imaginary lines, which will be a surrounding of this magnet, will call magnetic line of force. What do you say? Magnetic lines of force. Magnetic lines of force, or magnetic lines of force are simply forces of magnet. So what are magnetic lines of force? Imaginary lines where when iron fillings will sprinkle on that magnet, they will go and fall in certain pattern way. Or another way we can tell that this imaginary line which will join any 2 points of a magnetic field, that will called as a magnetic line of force. So why these iron fillings fill in this uniform pattern? Due to the presence of magnetic lines of force. Now, how these magnetic lines of force existing? Due to the existence of magnetic field. Now, what is a magnetic field? The space around the magnet, in that space, the region in a space around a magnet, up to where that magnet will influence, or the magnet will exert force of attraction or force of repulsion. That region is known as magnetic field. That means without any physical contact, these iron fillings simply falling in a certain uniform pattern way due to existence of magnetic lines of force, and that magnetic lines of forces are due to magnetic field. In that way, we can able to visualize magnetic force. This force is due to field created by this magnet. That's why this will come under forces at a distance by using the concept of field force. Field force. So magnetic force will come under field force. Why it will come under field force? Because the space around the magnet, in that space at a certain region, it will influence its force of attraction or force of repulsion. That you will call it as a magnetic field. Due to existence of magnetic field, these iron fillings, whenever they come within the magnetic field, they will fall in a certain uniform pattern way, which will call magnetic lines of force. And these magnetic lines of forces always come out from North Pole and enter into South Pole. And it doesn't have any end point. As this total bar magnet have total mass, we can't visualize inside the bar magnet. For bar magnet, outside of a bar magnet, the magnetic lines of forces will come from north to south, and within the bar magnet, they will move from south to north. but we can't visualize because we have presence of mass in this bar magnet. In this way, this will come under field forces at a distance, and also it is known as a field force. Field force. In this way, this magnetic force will come under non-contact force or forces at a distance, and also it is known as field force. So let us go for next example of field force or forces at a distance. So, types of forces in which we have contact force and non-contact force. We are discussing non-contact force. In non-contact forces also we have a kinds of forces. Number one, magnetic force. We completed. That magnetic force will come under non-contact force or force at a distance. Means even though they are not in physical contact, direct contact, these direct fillings are falling in a pattern way. Or in previous example, two iron needles will push away or pull towards themselves. That is because of field present around that needle or field present around magnet. Now next will come under gravitational force. So in field forces are forces at a distance concept, which will come with the help of a forces at a distance. In that forces at a distance concept, we are discussing about field force, which will field force. In that field force, we completed first one, that is magnetic force. The second one, gravitational force. Gravitational force. Now, what is the gravitational force? How it will come under non-contact force, or how it will come under forces at a distance, or field force. Now, I will take this chalk piece, and I will try to drop this chalk piece from certain height. Where it will go? It will go and fall on the earth. Or same this chalk piece, if I try to throw upwards, I will try to throw upwards by giving certain initial velocity, certain starting speed. Then, as long as it has certain velocity, it will move upwards against the earth, and whenever it reaches to certain maximum height, then it starts falling to the ground. Now the question is, why it will fall onto the ground? Why can't it go away from the earth? Because there is a gravitational force between the earth and the chalk piece, which pull the chalk piece towards the earth. That is known as gravitational force. So here, what is the gravitational force? The force of attraction between any two objects in the whole universe is known as gravitational force. Generally, we feel that gravitational force means force of attraction between planets, or force of attraction between earth and other body, or force of attraction between planet to sun. In that way, we will assume. But don't mean a mind that gravitational force means because of earth, or because of moon, or because of sun, or because of only planets. Between any two objects, suppose one sphere whose mass is m1, another object whose mass is m2. Then between these two objects, depending upon the distance d, or s also, or also you can write. Depending upon this distance, there will be a force of attraction if they are like objects, or if they are unlike objects, they will be attracted, or if they are like, they are repelling. So the force of attraction or repulsion will be there between any two objects in this universe, which leads to move, push or pull. That will call it as a gravitational force. Then immediately you will get down. If there is a force of attraction between any two objects, now if we drop this chalk piece, Why it should fall onto the ground only? Why should not it attract towards me? Or why should not it attract towards phone? Or why should not it attract toward the board? Or why it should not attract towards the other object? Generally, if you drop anything near by the earth, it will fall into the ground. Why? Because the force of it, because earth has huge mass. Depending upon the mass, the force of attraction will be there. That means force of attraction is directly proportional to m1 and m2. What is the m1 and m2? Masses of two objects. If they have more mass, the force of attraction or force of repulsion will be more. If they have less mass, their force of attraction or repulsion will be less. As Earth has huge mass, compared to Earth mass and other objects mass, Earth mass is more. Then if you multiply the product mass of our body and other Earth body, our product will be more compared to product of ourselves and other object. So this force is weaker compared to this force acting between Earth and other object. So as this force is dominating, it will overcome this force acting between me and the board, between me and the phone, or between me and the wall, or between me and the top floor, just top floor. And it will, because Earth has huge mass, so we will obviously fall onto the ground if you jump or if you throw any object. That means force of attraction is directly proportional to m1, m2. Force of attraction is inversely proportional, means if the distance is more, force will be less. If the distance is less, force will be more. That is 1 by d square. So in that way, we have a force. This force will call gravitational force. That's why if you throw any object upwards, it will fall onto the ground. Or if you drop any object, it will fall into the ground. Or like this, because of gravitational force. Now the question will, whether this force is acting by direct physical contact or without physical contact. Without physical contact only, the force is acting, pulling force. That's why gravitational force will come under forces at a distance or simply field force. How it will come under field force? Up to certain region of Earth, means above the Earth up to somewhat up to certain kilometers, it can influence its force of attraction. If you cross that limit, the Earth can't attract any other object. So that region you will call it as a Earth's gravitational field. So this force is due to the existence of field. That's why it will also come under forces at a distance or field force. Because of field only, this was the field created by the Earth mass, this force is applying. That's why it will come under the field force or forces at a distance. And already we discussed about electrostatic force. Why the electrostatic force? The force exerted by a charged body on other charged body is known as electrostatic force. So totally, forces at a distance will come under, or field forces will come under. There are three types. They are magnetic force, electrostatic force, and gravitational force. So these three will come under field forces or forces at a distance. The magnetic force, we discussed examples, electrostatic force, balloon example, or electric field created by the wire. Through wire the current passes, then up to certain region it can influence its force of attraction or force of repulsion. If you have a main wires which will come from the pole to our Earth, they are what we call main wires. So they will be very far away from house. They will be at height because they are already have charged body. However, they will be insulated. Insulator means which won't allow the flow of charge. If they are not insulated, then they can able to apply that force on other charged body, which will call ourselves or other bodies. As a result, there is a chance of electric shock. In this way, we have a forces at a distance or field force. So simply, how we will define the forces at a distance or field force? The force will be exerted between any objects without being directly contact or without any physical contact. The type of force which are applying between any objects, it may be a force of attraction or it may be a force of repulsion. That forces will come under forces at a distance or field force. Simply non-contact force. The next type is contact force. Where will apply contact force? Pushing an object, pulling an object. How will do all these activities? Even while explaining this lesson to you, I am going on exerting some force with by movement of these jaws and these lips. As a result, inside our body, some muscles are going on of exerting force. So that will call muscular force. Muscular force. That means if you are pushing this ball, or if you are catching the ball, or if you are hitting the what we call sixer, or if you are while you are running or while you are walking, then we are going on applying forces, exerting forces from our body due to the muscles. The type of force will come under muscular force, which will be applied due to muscles, which will come under contact force. In this way, two types of forces, they are contact forces and forces at a distance, are simply field force. Mainly these three will come under field force, whereas muscular force will come under contact force. That we can discuss elaborately later.